Okay, in previous video we learned about indices, so now we're going to look about the surds. Okay, what is surd? Okay, the surd is an irrational number in the form of nth root of a. Okay, where a is a positive integer and a is any real number. Okay, which is expressed in terms of root signs. Right, so this is what we call a surd, but not all nth roots it's a surd. It must be an irrational number. Okay, so for example, square root 9 is not a surd because square root 9 is equals to 3. That's not an irrational number. Alright, so for example, okay, irrational number that are surd, for example, is surd 2, surd 7, okay, cube root of 5. So this is surd. Right, and we also have irrational number but not a surd, which is a pi and e. Okay, e for Euler number. All right, so we look at rule of surds. Okay, the first rule is if we have two surd is multiplied together. For example, we have square root a times square root b, or surd a times surd b. Okay, that is equivalent to surd a times b. So this means we can combine the a times b inside the surd. Okay, second rule is surd a divided by surd b, that is equivalent to surd a over b. Okay, the third rule is if we have the two term has the same surd. For here we have surd b, okay, and a surd b plus or minus c surd b. When we have the same base, which is surd b, so we can combine them by factoring out the surd b, and then we can add or minus a plus a and c. Okay, and remember, this rule only applicable for a and b, which is a positive real number. Okay, so be careful. Right, for example, let's say we have surd 2 times surd 5. Okay, so we can use this rule. So this is equivalent to surd 2 times 5, and we know that 2 times 5 is 10. So this is equals to surd 10. Okay, this is correct. But for this, surd negative 2 times surd negative 5. Okay, we cannot apply this rule. Okay, we cannot do like this. We cannot take square root of negative 2 times negative 5, which is, if we count, is surd 10. But this is not equivalent because we already discussed before this that a and b must be a positive real number, and in previous chapter we already know that the square root of negative number is an imaginary number. Okay, so that's not a real number, so be careful when using these rules. Okay, so we need also to be careful when we use this rule. So surd a plus or minus surd b is not equivalent to surd a plus or minus b. Okay, don't do this. And if we have surd a plus surd b squared, that is not equivalent to surd a squared plus surd b squared. So be careful, don't do like this. Alright, so if we have surd a plus or minus surd b, okay, we must expand like a quadratic expression. Okay, for example 1. Okay, simplify. Okay, the first question is we want to simplify 2 surd 3 minus 5 surd 2 plus 7 surd 3 plus 2 surd 2. Alright, so for this question, first we can open the bracket first. Okay, and then we can regroup the same base, which is we can put the term which is has surd 3 together and surd 2 together, and then we can factorize the surd 3, and then we can factorize the surd 2. So we can solve the inside the bracket. So 2 plus 7 is 9, so we have 9 surd Alright, so I make a mistake here. So this should be 9 here. Okay, and this is negative 3. Okay, second example. Okay, 5 set 7 plus 3 set 5 minus 8 set 7 minus set 5. So first we can open the bracket first. So for the second bracket, we need to multiply by negative. So it become negative 8 set 7 and negative set 5 become positive set 5. And then we can regroup, okay, the same base, the same set. Okay, we can regroup the which is had the term set 7 and also the term set 5, and then we can factorize set 7 and set 5, and then we can simplify. This is equals to, so 5 minus 8 is negative 3, so negative 3 set 7, and 3 plus 1 is 4 set 5. Alright, so you can do this exercise for more understanding. Alright, so now we're going to look how to rationalize a third fraction. Okay, the choice of multiplier on is by no means accidental. When more complicated expression need rationalizing, the multiplier simply the conjugate of the original denominator. So if we have an expression set A minus set B, the conjugate is set A plus set B. The most simplest way to think about this is we just change the sign in the middle. Okay, also the same here. If we have A plus set B, so the conjugate is just A minus set B. Okay, so this is what we call a conjugate. So if we have an expression set A minus set B, the conjugate is set A plus set B. So if you multiply, okay, the set expression with its conjugate, so what we have, so first if we multiply set A times set A is A, and then set A times negative set B is negative set A negative set A times set B, and then positive set B times set A is positive set A times set B, and positive set B times negative set B is negative B. And we can see we can cancel out set A, set B. So what is left is A minus B. Okay, so that what we have if we multiply the set together. Okay, so we look at an example here. Okay, rationalize the following. The first example is to rationalize 14 over set 7. So what we mean by rationalize? Okay, rationalize, we don't want the set to be at the denominator. So we want to make the denominator become a real number. Okay, no set anymore at the denominator. So how to achieve that? We can multiply, okay, the whole fraction with the conjugate of the denominator. So the conjugate for the denominator is negative 7, but we multiply the numerator and denominator, so the negative sign become positive. Okay, so if we multiply, we get 14 times set 7. Okay, set 7 times set 7 is 7, and then we can simplify. Okay, 14 over 7 is 2, so this is equals to 2 set 7. Okay, B 1 over 7 minus set 2. So we want to rationalize, so we take the conjugate of the denominator, which is 7 plus set 2, and then we multiply to the numerator and for the denominator. So for the numerator, it's become 7 plus set 2, and for the denominator, it's become 7 to the power of 2 minus, okay, set 2 power 2. And then we can simplify this, 7 plus set 2 over, okay, 7 squared is 49, square root 2 power 2 is 2, so 49 minus 2 is 47. So when we rationalize this expression, it becomes 7 plus 2 over 47. Okay, third example. square root 2 plus 3 over square root 2 plus 1. Okay, so to rationalize this, we need to multiply with the conjugate of the denominator, which is 2 plus surd 2 plus 1. So the conjugate is surd 2 minus 1. So we multiply to numerator and denominator. Right, so for the numerator, we just expand. Okay, we have surd 2 times surd 2 minus negative 1 times surd 2, positive 3 times surd 2, and again 3 times negative 1 is negative 3. And for the denominator, okay, when the surd expression multiplied with its conjugate, that is equivalent to surd 2 to the power of 2 minus 1 to the power of 2. And then we can simplify. Okay, surd 2 times surd 2 is 2. Okay, negative 1 surd 2 plus 3 surd 2 is 2 surd 2 and negative 3. Okay, we just copy back. And for the denominator, surd 2 to the power of 2 is 2 minus 1. And 2 minus 1 is 1 for the denominator. And 2 minus negative 3 at the numerator becomes negative 1. So that is equivalent to 2 surd 2 minus 1. Okay, first example. Okay, 1 plus surd 2 over 1 minus surd 2 plus 1 minus surd 2 over 1 plus surd 2. Alright, for this question, there are two ways to do it. Okay, we can rationalize each of these fractions first and then we can combine, or we can directly combine first these two fractions to become one fraction and then we can rationalize later. But for this question, if you realize that the denominator for the second fraction here is the conjugate for the first denominator here. So that's mean if we cross product these two fraction is already done with multiplying the conjugate. So we just cross product these two fraction. Okay, and it happened to be is multiplied with its conjugate. So we simplify, we get like this, and then for 1 plus surd squared, we can expand. It's become 1 plus 2 surd 2 plus 2. And for 1 minus surd 2 squared, if we expand, it's become 1 minus 2 surd 2 plus 2. And for the denominator, if we expand, it's become 1 squared minus square root 2 squared. So for the numerator, we can cancel 2 surd 2. Okay, because one is positive, the other one is negative. We can cancel that. So it's become 1 plus 2. Plus 1 plus 2, and for the numerator here that is just 6, and for the denominator that is equals to 1 minus 2. So 1 minus 2 is negative 1. So 6 over negative 1 is negative 6. Alright, so for rationalizing the denominator, when the square root occur in quotient, it is customary to rewrite the quotient so that the denominator contains no square root. In rationalizing the denominator of a quotient, be sure to multiply both numerator and denominator by the same expression.